Hello dear students. Today I am going to discuss one more most frequently asked question in our Board of Intermediate Examinations. It comes from collisions. This question is very interesting, very easy. The question is like this. They ask define collision. What is a collision? And they ask you to find the final velocities of the objects after collision. So first let us look at the definition of collision. It says that the phenomenon in which exchange of momentum takes place is called as a collision. For example, if there are two bodies, this is one body and this is another body. Initially it has 10 units of momentum. It has 0 units of momentum. So what is the total momentum? 10 plus 0, which is equal to 10. They have undergone some physical phenomena, means they may physically touch or they may move close together. I am not exactly saying that they are physically touching, but there is something happened because of which its momentum has become 4 and its momentum became 6. Now what is the total momentum? Is equal to 10. Means the total momentum is constant, but what happened? They interchange. What happened? Momentum got distributed. Redistribution of momentum take place. So its momentum got something distribution took place. So such phenomenon is called as collision. So what is collision? The phenomenon in which the redistribution of momentum takes place is called as a collision. Here in this example, you have seen that the momentum was 0. The momentum earlier it was 10. Now also it is 10. It may be like this also: 5 plus 5, 6 plus 4, 0 plus 10. Anything could be possible. So in all these cases, momentum got redistributed, and all these phenomena are best suitable examples for collision. Now let us go into the actual derivation part, in which we are going to show several aspects, like the relative velocity of approach is equal to relative velocity of separation. We are going to prove coefficient of restitution E is equal to 1. We are going to prove. Finally, we are going to find the formula for velocities of the two bodies. Okay. Consider there are two bodies of masses m1 and m2 are moving with velocities u1 and u2. So in this picture I am showing both are moving in the same direction, but it is not necessary. They may move in same direction or they may move in opposite direction, doesn't matter. But in this particular example, I am taking that they are moving in the same direction. So as to execute collision, u1 must be greater than u2. This is my condition. Here I am going to take two cases. One is before collision and the other one is after collision. So before collision they are moving separately in the same direction. So the total momentum before collision is equal to momentum of the first body and momentum of the second body. What is the momentum of the first body? m1 u1, and momentum of the second body is m2 u2. Now something happened. It hits the second body and they move apart like this, but their velocities got changed because of this collision. Maybe its velocity is v1 now, its velocity is v2. Masses are not exchanged, it's m1 and still it is m2 only. So after collision, what is the total momentum we are going to study now? Is equal to m1 v1 plus m2 v2. As we are already defined this as a collision, the momentum must be conserved, means initial momentum must be equal to final momentum. So P1 is equal to P2. So I am going to equate these two. Now M1 U1 plus so I have just equated this and this. I am going to rearrange these terms, all M1s in one direction, M2s in other direction. Now it will be now I am taking just M1 as common here, M2 is common here. So I am going to keep it aside. Now in the problem he stated that the collision is elastic collision. Elastic collision means the kinetic energy also must be conserved, means the kinetic energy before collision must be equal to kinetic energy after collision. Now let us see what is the kinetic energy before collision. The kinetic energy before collision is kinetic energy of this and kinetic energy of this. The kinetic energy of this is half m1 u1 square, kinetic energy of the second body is half m2 u2 square. Now the kinetic energy after collision is kinetic energy of the first body and kinetic energy of the second body after collision, that is half m1 v1 square plus half m2 v2 square. As per our definition, the total kinetic energy also conserved, means kinetic energy before collision must be equal to kinetic energy after collision. So I am going to equate these two. I have done nothing, I have just equated this equation and this equation. This half get cancelled. Now I am going to write m1 terms in one side and two terms in other side. Okay. So I am going to take this in the left direction, this is towards the right direction, and I am going to write this. I hope you are following the lecture. I hope you have notes and a pen with you. Wherever required, pause the video and note down and then resume the video. Okay. Now I am going to write m1 terms towards left and m2 terms towards the right. m1 u1 square, this is towards left, it is as this, this is towards the right, now I am going to take m1 as common here, m2 as common here. Is it like a square minus b square? So it can be written as a minus b into a plus b. Say this is equation number 2. This is already equation number 1. I would like to make 2 by 1. So by doing 2 by 1, this is m1 into, I am writing same as it is. I can cancel m1 and m1, this m2, m2, this and this. So what are left with? Here left with this term and this term. note down. Now I am going to rearrange these terms like this. This is towards left, this is towards right. So this is u1 minus u2 is equal to, this is v2 minus v1. We call this as the relative velocity of approach before collision, and we call this as relative velocity of separation after collision. So hence it is proved that in case of elastic collision, it is proved that the relative velocity of approach before collision is equal to relative velocity of separation after collision. In some exams they may ask you that prove that coefficient of restitution is equal to 1 in case of elastic collision. If they ask like this, just do one more step, otherwise ignore that. So if they ask you to prove that E is equal to 1, what we have to do? As per the definition of E is equal to the ratio between relative velocity of separation after collision to the relative velocity of approach before collision. So E defined as v2 minus v1 by u1 minus u2. So in this case both are equal. So as these are equal, E is equal to 1. It is proved for elastic collision. If they don't ask you in an intermediate exam about E is equal to 1, just skip this step. Solve till here. Generally they may ask you this for 4 marks. If they ask you for 4 marks, just stop here. If they ask you in 8 marks question, they will ask you about v1 and v2 values, then you have to continue further. So how to continue, we are going to study now. See, this is, let us name this as the third equation. We have already first equation with us. By using these two equations, we can find v1 value and v2 value. Okay. So as to find v1, we have to eliminate v2. And so as to find v2, we have to eliminate v1. So how to eliminate v2? From third equation, we can write that v2 is equal to, just send it towards left, u1 minus u2 plus v1. Say this is 4. Put this fourth value, means v2 value here, and simplify. So what is this? I am going to expand m1 u1 minus m1 v1 is equal to m2 into, instead of v2 I am writing this, u2 is earlier already there. So upon expanding this, I get m2 into u1 minus this is u2, this is u2, minus 2u2 minus 2 m2 u2 plus m2 into v1. This is same. What is our aim? Our aim is to find the value of v1. So I am going to bring v1 one side and v remaining in other side. I am going to move this towards right and remaining terms towards left. So this is m1 u1 minus m2 u2 plus 2m2 u2 equal to m2 v1 plus m1 v1. Now anything is there? Yeah. I can take, upon taking u1 as common, this is m1 minus m2 into u1 plus 2 m2 u2 is equal to, upon taking v1 as common, it is m1 plus m2 into v1. Now our aim is to find v1 value. So as to find v1, we can send this towards left. If we can send this towards left, we can find the value of v1. Over. This is our standard formula for final velocity of the first object. Similarly, we can find the final velocity of the second object. As we already know that now our job is to find v2, means we have to eliminate v1. So from this v1 is equal to how much? I am going to substitute this in our previous equation. So that is m1 into u1 minus instead of v1 I can place is equal to m2 v2 minus m2 u2. Upon expanding this, it is minus of minus plus, minus into plus minus, now as our job is to find v2 value, I am going to keep v2 in one side and other terms in other direction. So I am going to send this towards right, this towards left. Now it will be m1 u1 and m1 u1, it becomes 2 m1 u1, this is over, this is over, this is left with minus m1 u2, and it becomes a plus m2 u2 is equal to m2 v2 plus m1 v2. Observe this carefully and you try it yourself. It is a simple linear equation only. You have solved this in your 8th standard itself. Actually explanation is not required, but for my satisfaction I am giving this. So even if you don't follow my explanation, you can do it yourself. In general, in classroom I never discuss this. My students automatically do it. Now 2 m1 u1, I am going to take u2 as common and also minus, it is minus of m1 minus m2 into u2 is equal to, I am going to take v2 as common, so it becomes m1 plus m2 into v2. Now what is our task? Our task is to find v2. So upon sending this towards the left, we can find v2. So our v2 becomes that's all. This is our formula for final velocity of the object, second object after collision.